Okay, so get ready to put your math skills to work to solve this interesting little math word problem. Matter of fact, let me go ahead and read the problem. It is the following. A baseball goes three-fourths of the way from first base to third base on a 90-foot baseball diamond. How far did the ball go? All right, so this is the problem. Feel free to use a calculator, and I'm going to explain this problem more here in a second. What you want to do is take the most simplistic view of what's going on in this problem. But if you don't know what a baseball diamond is, or if you don't understand the question, I will review it in just 1 second. But if you can figure this out, go ahead and put your answer into the comment section. I'll show you the correct answer in just 1 second, and of course, we'll walk through exactly how to solve this problem step by step. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And if you need help learning math, well, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, make sure to like and subscribe, as that definitely helps me out. All right, so hopefully most of you know about baseball. It is a fantastic sport. But again, some of you out there may not have played baseball or don't understand the problem. So let me explain it so you have a full opportunity to solve this thing. Okay, so a baseball, right? So we're talking about a ball goes three-fourths of the way from first base to third base, right? On a 90-foot baseball diamond. All right, so real quick here, a baseball diamond. We're talking about the sport of baseball. So I'll just do this real fast here, and we're talking about American baseball. Matter of fact, don't know if there's another baseball. If you know the answer to that question, put that into the comment section. But here is a gigantic baseball field. Now, way down here is the baseball diamond where you have the bases. So you have like first base right here, second base. You have third base, and then this is home plate. This part is the diamond. So a 90-foot baseball diamond is the distance, 90 feet is the distance from each base. So from home plate to first base is 90 feet, from first to second, 90 feet, et cetera, et cetera. Now, one thing about a baseball diamond, it is not like a diamond like this, all right? It's pretty much a square. And here is a little bonus question. What do you call this type of figure that is a diamond with equal sides, but does not have right angles? Because our lovely baseball diamond is actually a perfect square that's tilted to form a diamond. Okay, so if you know the answer to that little bonus question, put that into the comment section. The answer is that's called a rhombus, right? So a baseball diamond, you want to think of that as a square. All right, so we also need to take a very simplistic version of this problem, right? Now, I'll show you the answer here in just 1 second. And in actuality, if a baseball player throws a ball, the ball is going in some sort of perfect little arc like this, right? Even if they're throwing it real fast, it's losing a little bit of altitude because of gravity. We don't want to be thinking in those terms. And we also have to just assume that this baseball is being thrown perfectly at the corner of first base, going perfectly to the corner of third base, right? So we're going to take a very simplistic version of this problem. All right, so hopefully all of that explanation cleared up the question. Now let's go ahead and take a look at the answer. The correct answer is approximately 95.46 feet. All right, so that's about three-fourths of the way from first base to third base on this 90-foot baseball diamond. And if you got this right, well, we have to celebrate by giving you a nice little happy face and A plus a 100% and multiple stars. So you can tell your friends and family that indeed you understand how to solve right triangle word problems, because really what's going on here is we have a triangle situation. And if you don't really understand what's going on, if you're like, well, Mr. YouTube Math Man, I am a little bit lost on this problem. Well, let's go ahead and get into it right now. This is not that difficult. Okay, so first things first. First, we are dealing with a math word problem. So always read the problem at least 3 times. Now, I went through the problem already a few times, but if you don't understand any aspect of any problem, you need to, ask your teacher or look up if you happen to be a student. But if you don't understand a problem, let's say you're doing homework or just learning math on your own, you need to stop, look up whatever aspect of the problem so you fully understand it and understand the information in the problem. Now, a little bit of a hint out there. If you have a math word problem like this, never try to overcomplicate it. Okay. In other words, don't be like, well, what happens if the baseball goes like this? It's not traveling in a perfect line. Always take the simplest version of a math word problem. You can never go wrong because if your teacher wanted you to take a more complex version of it, you'll know it because you'll probably be in some sort of class like calculus or physics. All right, but for those of you that are studying basic algebra and geometry, again, you want to take a simplistic view of this problem. Now, if you're not sure, again, ask your teacher or try to double check. All right, so we kind of went through the problem, and once we understand what the problem is, we want to figure out what three-fourths of the way is from first base to third base. Well, it's going to make sense to draw out a lovely little picture of this situation and evaluate this information so we can figure out what to do. So let's go ahead and take a look at a nice little sketch of a baseball diamond. Okay, so again, this is part of a baseball field. And here is home plate. Then you got first base. So those of you that don't understand how baseball works, here's our lovely little baseball player. They hit the ball, boom, and then they're going to run. They're going to start, right? You got a pitcher over here. And I don't want to explain baseball, but basically, for those of you that are curious, someone's going to hit the ball, and then they're going to run from what? They're going to go from home plate to first place, and then second, third, etc. And then if they make it all the way around, they score a run. All right, so that is baseball in 15 seconds, but we're concerned about the distance from first base to third base. Now, one thing about this baseball diamond, we're being told that is a 90-foot baseball diamond. I believe in Little League, I think the distance between the bases, I could be wrong, but I think it's something around 60 feet. So some baseball diamonds are not full size. I believe 90 feet is what the professionals use. Again, some of you out there probably know the exact answer to this, but really that's not that important here. What's important is that we understand that 90 feet is the distance from each base. Okay, so it's 90 feet. And I did my best to kind of draw a square. I could have done a better job, but don't let this kind of fool you. Basically, what we have here is a square. So these are right angles right in here. Okay, so we got right angles, and we want to know the distance from first base, or actually not from first base to third base, right? So of course we're interested in this distance, but we want to know how far is three-fourths of the way from first base to third base. So to figure this out, we're going to have to get the distance from first base to third base, and then we can figure out what three-fourths of the distance is right there. Now, because we have some right angles, and it looks like we're forming some sort of triangle, you might want to be thinking about a right triangle to solve this problem. So if this is what you were thinking, you're like, you know what, I think this is a right triangle situation. Well, you are thinking correctly, and now we can kind of distill this problem down into this situation. Okay, so right here, again, we were dealing with a right angle, and what we need to concentrate on is from home plate to first to third. All right, so we want to get this distance here from first to third, whatever distance this is. All we need to do is find three-fourths of it, and we will have answered the question. Okay, so at this point, it makes sense to just kind of concentrate on a right triangle right there. Now, some of you probably can just figure it out by this little diagram right here, but I'm going to break it down a step further so those of you that don't know what's going on can see precisely how to solve this. Okay, so here is kind of a cutaway of our baseball diamond. Right here would be our home plate, right? So we kind of tilted it. So you're going to go to first, and then you got second, and then you got third, like so. All right, so 90 feet from home to first, right? And then from home to third is 90 feet. So we are dealing with a right triangle, okay? Now we have the lengths of the sides of the right triangle. We're looking for this distance right here. Now, the longest side of a right triangle is called the what? It starts with an H, and if you know the answer, type that into the comment section, but it's called the hypotenuse. And we can easily solve for this distance right here, but we need a fantastic formula. Matter of fact, it's called a theorem, which is basically a property or a kind of a law, not to get overly technical, but a theorem, right? So For those of you that are studying geometry, you study a lot about postulates and theorems, but that's not really important. What's important is that there is a way for us to figure out the distance between first and third base. Okay, so how do we do that? Well, we're going to need this lovely formula right here. Okay, so this formula, okay, is actually referred to as the Pythagorean theorem, right? So hopefully I'm not slurring that word too much, but it's probably one of the most famous theorems, formulas that you will see in all of geometry and all of mathematics. If you're not familiar with it, well, this is definitely a formula that you want to put into your long-term memory. All right, so how does this work, or what is this saying? Well, a squared plus b squared is equal to c squared. So what this is saying is anytime we have a right triangle, and our triangle has to be right, and let me go ahead and define what a right triangle is right now. That means that this triangle has a 90-degree angle right in the corner, and this little symbol right there, this little box, indicates that this angle is right or 90 degrees. Okay, so that is a right triangle. Now, if you don't have a right triangle, well, you cannot use this. So in other words, if you have a triangle like this, you can't use the Pythagorean theorem in this form. Actually, there is another formula, equation that you can use. This is, for those of you out there that are curious, you want to look up the law of cosines and the law of sines. These things will help you figure this out. Matter of fact, the law of cosines and sines, or actually particularly the law of cosines, is kind of like a long version of the Pythagorean theorem, but that's for those of you that are interested in more advanced math. Okay, so a squared plus b squared is equal to c squared. So what this is saying is that if we have the two shorter sides of a right triangle, we can figure out the longest side, or if we have two out of any three sides of a right triangle, we can figure out the other side as well, because if you had this side, C is always the hypotenuse. It's always the longest side of a right triangle, and it's always opposite of the right angle. Okay, but in this particular case, here is how we want to look at this theorem or this formula. So we're going to square this side, a squared, and then we're going to add it to the square of this side. Then we're going to add all that up. That's going to be equal to this side squared. So we can just do some basic algebra to solve for C. Now there is another super cool little shortcut that we can take to solve this particular problem. I'll show you that little shortcut as we get through the solution. But this is the Pythagorean theorem. Okay, so this is what we need in order to solve this problem. And let's go ahead and take a look at how we're going to use it specifically to figure out the distance from first base to third base. Okay, so again, our sides of our triangle are 90, so this would be 90 here would be like our A, 90 here would be like our B. So if you want to kind of follow along, go ahead and plug in these numbers, square them, add them together, and let's see what you come up with. Okay, so this math is not that difficult. Again, feel free to use a calculator, but we have 90 squared plus 90 squared is equal to c squared. All right, so what's 90 squared? Well, 90 squared is 8100 plus 8100, which of course is 90 squared. We're going to add those two together. We get 6200 is equal to c squared. Okay, so how do we figure out what C is? Well, that is very easy. All we have to do is take the square root of both sides. So let's go ahead and take that next step, which of course is having you quickly subscribe to my YouTube channel. Now, I wouldn't stop this lovely math video if I didn't need your support. You see, I'm asking for your help. And if you are having a tough time in math, you shouldn't be afraid to ask for help. Now, my whole goal here with my YouTube channel is to reach as many people as I possibly can to teach them math. Because as a math teacher, it does me no good to just know the math myself. I want to teach people who need assistance in learning math. Now, I'm pretty happy that my channel so far has got like 85 million views since, I've been on YouTube, which is fantastic. I'm hoping that, I've really helped some people along the way. I'm sure I have, but I'm just not satisfied with 85 million views. It's not about views, it's about people. Okay, so I'm passionate about helping individuals, people learn math. It's just one of these topics that so many people have this kind of situation. They're like, I'm bad at math, And I just, oh, that is just the worst because this is not true. Okay, it's not true. And if you think that, well, you were never good in math in school or, you're bad at math, please do not think this. This is not the case. I can tell you right now, you can learn math very, very well, but it takes effort, it takes time, and most of all, it takes great instruction. So if you need help in mathematics, check out my full math courses. For what we're talking about right here, any of my courses like pre-algebra, algebra 1, geometry, I will teach you all about the concepts that we're talking about in this particular course. And if you're not a student and you just want to learn some math from me, check out my Math Skills Rebuilder course. But anyways, thank you for giving me a little bit of time to explain what my channel is all about. Now let's go ahead and finish this problem up. So we got 16,200, excuse me. I think I said 16,200 previously. Well, if I didn't, I'm saying it now. All right, so 16,200 is equal to c squared. So let's just back up here. And remember, we got 16,200 from squaring the sides, right? 90 squared plus 90 squared, 8,100 plus 8,100. 16,200 is equal to c squared. So to find c, all we have to do is take the square root of both sides. Okay, so when we take the square root of both sides, we're going to get approximately 127.28. So I'm just kind of rounding off a bit. So that's what C is equal to. But what does C represent? Well, that is the distance from first to third base. And remember, we are dealing with units of measure, and we're talking about feet. So we're talking the distance from first to third base is 127.28 feet approximately. Okay, but remember the problem is it's not what is the distance from first to third base, okay, that this ball was traveling. It's a 3/4 of the way, right? So we're talking about from first to third base, this ball is traveling 3/4 of the way. So where is it right here? Well, we just have to find 3/4 of this number and we will answer the question. All right, now before we do that step, let's take a look at a quick little shortcut that would make this problem so much easier. And hopefully some of you picked up on this. I'm sure a lot of you did. Now this particular triangle, not only is it a right triangle, it is a special right triangle because anytime you have a right angle where the sides are equal, okay, we're dealing with a square here. Remember, we're kind of looking at our baseball diamond. Here's home, first, second, and third. So we're kind of looking at the diagonal of a square, okay? Now, if each one of these angles here is 90 degrees and we are kind of bisecting these 90 degrees here, well, these angles right here are 45 degrees. So 45, 45, and 90. So in geometry and trigonometry, when you have a 45, 45, 90 degree triangle, this is a special right triangle because you can take a lovely shortcut and you can kind of bypass the Pythagorean theorem to figure out what the hypotenuse is because the sides are the same. So to figure out this number right here, instead of doing all this a squared plus b squared business, the way it works when you have a 45-45 special right triangle, so let me just kind of show it to you this way. So the sides are going to be equal and we have a right triangle. So let's say whatever length, let's say this is x, distance from here to here, well, so is this. The hypotenuse is going to be x times the square root of 2. That's the same thing as going x squared plus x squared is equal to c squared and doing all this, Pythagorean theorem stuff. You could just say, oh, this is a 45-45, take this length and multiply by the square root of 2. So if some of you figure that out, well, that is outstanding. And let's go ahead and just check that and see if we get the same answer. So 90 times the square root of 2, if you plug this in your lovely calculator, you're going to see you're going to get the exact same answer as all the number crunching that we did with the Pythagorean theorem. Okay, so that is the full distance from first to third, but this ball only goes 3/4 of the way. So all we have to do is take 3/4 of that number, and 3/4 times 127.28 is approximately 95.46. Again, we're talking about units, the units of measure here being feet, and that is that. Okay, so again, you have to take a very simplistic view of this problem because in actuality, if the baseball is traveling, this would be a great physics problem, and you would need, more advanced math to actually kind of figure this out. But you can learn that stuff. Matter of fact, if you are interested in physics, I'm sure a lot of you out there have taken physics. Physics is an awesome course. I would just really encourage a lot of you out there, if you like science, if you like math, well, then, there's nothing better than physics, in my opinion, because it's an application of math. And you can see how it works, in science, with, gravity, electricity, force, mass, all that kind of good stuff. So, anyways, I would really encourage you to take physics if you haven't, if you want to. But before you do, you really got to know some math. Okay, so if you need additional help with any of these math concepts, check out my additional videos on my YouTube channel. And if you need full course instruction, you know where to find it. Just check those links in the description of this video. All right, so with all that being said, I definitely wish you all the best in your math adventures. Thank you for your time and have a great day.